So yeah, there's three main reasons why you should join Midnight Sun. First, learning and experiences. We are a student design team, and as a student design team, you will learn skills and gain practical experiences that you wouldn't necessarily in terms of school academics. So it's really cool where you can work on unique projects, which is my second point, and gain these experiences and sharpen your skills or develop your skills. And Midnight Sun is working on a unique project. We are creating a solar car from scratch, and we have a lot of steps in between these projects, so it would be really cool to participate in this project. And also our community is great. We are a passionate student who loves to work on a common goal, and it'll be really nice. You will meet a lot of cool students, and yeah, that's literally one of the huge reasons why you should join Midnight Sun. Next slide, please. So yeah, I will be answering some of the most popular FAQs in the beginning of each first general. So first would be, do I need to apply to Midnight Sun? No, you do not have to. If you are here, this is your first step. Just make sure to follow the next steps that we will be talking later on, and make sure to just communicate with us and show up to the meetings, and that's all good for you. Second, can I join even if I'm not experienced? We are a strong believer that the best student member is not necessarily the best skilled. So if you do not have any experiences, we are totally okay with it. Please come out and just participate, and you will just gain awesome skills during these times. And third, how much of a commitment is expected? We often say how much you put in is how much you gain out of it. So if you don't have that much time but still wants to work with us or try these projects, please do. If you are committed more and if you want to put more time and more of your skills into it, awesome. It's just that you would gain what you put in. So it really depends on you.
Yeah, and I'll be answering this last one. What will the winter 2022 term look like? Will it be in person? Will it be remote? I guess right now a lot's up in the air, as you can probably imagine, with the pandemic. However, a lot of the sub teams are part of their research stage right now, and so most of the things you will be doing are going to be remote, at least for this term. And yeah, next slide. Yeah, alrighty, so before we get into sub teams, I guess, are there any questions just on like the general team? Just raise your hand and unmute, and then we'll answer them. Alrighty, if there's no questions, then I guess we can hand it off to Aiden with mechanical.
All right, hello. My name is Aiden. I'm in 2A currently. I am going into this new year with a sense of enthusiasm and passion. I'm really excited that we got a big turnout tonight. It's going to be a lot of fun for anyone who's interested in joining the mechanical sub team. I'm currently the mechanical technical manager for the team. And just a bit about the mechanical sub team. Our purpose is to research and design, manufacture, assemble, and test the physical vehicle. We've got multiple sub teams here, so depending on what you're interested in, I'm sure that there's something that we can get you started on. We have the chassis sub team led by Ali, the aerobody sub team led by Michael, the dynamic sub team led by Jens, and the battery box sub team led by Owen and Eric. Our term goals for the chassis, aerobody, and dynamic sub team is to continue to set up the bay, a little bit of organization and getting ready for when we can be on site, getting a lot of member training done. We got a lot of inexperienced members, new members, returning members, and leads who all need training, and it's going to be an essential step to making sure that we're all on the same page. So that's going to be a heavy focus for this term. And we're going to be doing some vehicle research. So a lot of these are offsite tasks that you guys can pick up at any skill level. But it's important that we understand and we learn what we need to know about the vehicle. So this research is going to be crucial. So if you want to get involved in that, let me know. Additionally, we have some term goals for battery blocks, which also includes member training, battery research, and initial module design. I think next I'm going to hand it off to Ali.
Hey guys, so I'm the chassis lead starting from this term. So I was previously the interiors lead for MS14. So if you're interested in chassis, I'll just give a quick rundown of what that entails. So just for the new members, or if anyone that's just interested and doesn't know, I'll give a brief explanation of what a chassis is. So a chassis of a vehicle, it provides the strength needed for supporting the different vehicular components as well as the payload, and helps to keep the car rigid and stiff to maximize safety and driving performance. So it's essentially the frame of the vehicle and holds everything together. So it's a pretty big part of any vehicle, especially for our purpose. So on the chassis subteam, we'll be researching, designing, and manufacturing the entire chassis of the car. So some projects that you can expect, especially for this term, there'll be research and conceptual design heavy. So at the moment, we're kind of at the research phase where we're essentially trying to train members and learn everything that needs to be known before we can dive into the actual designing of the chassis. So an example would be researching different ideas and coming up with concept chassis designs. So just an example of that would be on the right side. You can see on the top image and on the bottom image. So those are just two concept designs of what a Challenger class solar car can look like. So an example project would be researching the pros and cons of either design and how we can benefit from different types of chassis. Later on in the design cycle, we will also be doing static structural analysis using FEA to test and optimize chassis concepts. So essentially, we'll be using FEA to make sure that the structural rigidity of the chassis passes regulations that are required by the American Solar Challenge organization. So yeah, if you guys are interested in chassis, be sure to reach out, and yeah, you want to move on, or if you want to.
So hey everybody, I'm Michael. I'll be the aero body lead, and currently I'm in 2A nanotechnology engineering. So basically what we do on the aero body team is we research, design, and manufacture the aero body of the car, which is basically just the shell of the car. And to put it like really simply, we want to make the car look good while making it easy to manufacture while still maintaining a good aerodynamic performance. And some of the projects that we might see throughout the term and in future terms as well is just aero body conceptualization and design, and DMF just stands for design for manufacturability, because again, we are a student team. We aren't in we don't have access to complete professional equipment like big car manufacturers do. So we need to design to our capabilities and think how we are going to integrate things with our other sub-teams, such as the chassis team. Then we would also look at computational fluid dynamic simulations, which is the picture on the bottom right. So that's how we can analyze our aerodynamic performance, making sure that we have optimum angles at the nose of our car, the cockpit, and around the sides, so we get optimal airflow. And then also, while we are designing and whatnot, we need to think about how we want to integrate our panels together and how the molds will look for that as well, because again, we always got to keep in the back of our mind, can we actually build this properly, and will it be able to fit our timelines? So if you guys have any extra questions about aerobody, make sure to reach out to me on Slack, and I'm available anytime to chat. So thank you.
Okay. I hope you guys can hear me. So I'm Jens. I am the dynamics lead for this turn, or this car. So what is dynamics? Dynamics is all the moving parts on the car. So we mainly look at the suspension, the steering, the brakes, and in general, anything around the wheels. If you have a harder time conceptualizing it, the best way to think about it is that you study statics in physics, which is the study of rigid objects, so things that don't move or shouldn't move. Dynamics is the opposite. Everything moves. Everything needs to be considered in that frame of reference. So the types of projects we're looking at right now are suspension, steering, and brakes, because those are the three big subsystems that we focus on. Now, like every other subteam, we're doing a lot of research right now. So we want to build a very strong foundation of knowledge to be able to design and architect these very important subsystems correctly. There's also a little bit more in the regulations. So for steering, for example, we have to make sure that we can complete a certain turning radius in I believe 8 seconds. And there's a figure 8 course that we have to map out. So we have to do the calculations to be sure that our steering is rigid enough and can hold itself to complete it while still meeting the angles that we need. And a lot of this is dependent on chassis and aero, because depending on what aero design we have, we might need more mechanisms to control our wheels. Or for the chassis, we need to know wheel placement to be able to determine the geometry for our steering and those sorts of things. And then, of course, mass goes into brakes. Just a real quick overview of the sort of stuff that you're dealing with. There's a lot of math calculations, there's a lot of design, architecting, but a lot of it comes with research. So that's what we're at now. If you have any questions, feel free to ask me about dynamics. I've also been around mech for a little bit, so feel free to ask me about that as well. And yeah, I think that's everything for dynamics. Hope to see you guys around.
Hi everyone, I'm Eric. I just finished my 2A term in mechatronics engineering, and I'm one of the co-leads for Battery Box.
Hello, I'm Owen, and I'm also in 2A Tron, and I'm the other co-lead for Battery Box.
So just a little bit about Battery Box. The Battery Box team works on everything battery related, as well as electrical mechanical integration. So far, being early in the design cycle of our new car, most of the focus has been on preliminary research, similar to all the other teams. But this is for our battery pack, which will be storing the energy collected by our solar arrays and supplying that energy to the car whenever it's needed. So over the long term, as in across the entire cycle of this car, we will be designing the battery pack with considerations to the requirements of the electrical system, designing modules and enclosures for the battery arrangements, as well as the mounts and other parts that allow for the integration of other electrical components into the vehicle. Once all the research and design is wrapped up, we'll also get into actual manufacturing and assembly of the battery pack. So if you're looking to get experience with a little bit of both electrical and mechanical aspects, you might want to give Battery Box a try.
Right, and for this term in particular, the goals are to research and get a solid foundation on batteries and to conduct some preliminary designs for the battery modules. And to quickly explain what the module is, the cells are connected in parallel in a module, and then those modules kind of act like larger batteries, which are connected in series to form the battery pack. So you can see in the two center CAD models of the previous module design on this slide. So like the smaller design on the top would be a module of parallel cells, and the large assembly at the very bottom is the modules all connected in series to form the entire pack. So when we say we're designing modules, we mean a container for a certain number of cells in parallel, and we would be doing that in CAD. So some things you'll get exposure to this term with Battery Box are batteries, of course, and SolidWorks for designing the modules, some 3D printing when we create prototypes, and potentially battery testing of cells near the end of the term. Yeah, and that wraps it up for Battery Box segment. If you're interested, you can learn more by joining the channel in Slack. You can message Eric or I, and be sure to come to Saturday's 101 session where all the subteams will go more in depth. And then now we'll pass it over to hardware.
Hey everyone, I'm Alistair. I'm one of the leads for hardware. I'm going to be talking a little bit about what hardware does. So simply put, we design the electrical systems in the car. So like as an electrical car, we have the important responsibility of making sure all the electrical systems function properly. And we have to account for like any kind of electrical faults. So we are basically responsible for doing all that. And yeah, so if you just look at it at the high level, we split our systems into high volt systems and low voltage systems. So our high voltage systems consist of the battery, the motors, and the solar panels. So we don't design, like we don't construct the batteries. That's battery box. They make the box itself, and we don't make the motors from scratch. But we do have to like interface or communicate with them effectively so that we don't end up blowing stuff up. Yeah, but we do design from scratch. I would say almost all the low volt systems, all the boards, all the circuitry, and yeah, driver controls, battery management, telemetry, power distribution. In the next slide, we're going to see a little bit more about what our low voltage systems split into. So yeah, next slide. Oh, actually, that's afterwards. But yeah, this is the team. I'm one of the co-leads along with Lucy, Kevin, Ricky, Odie, and Danish. And Neera is the team lead. She's going to be with us for the next 4 months because she was one of the leads for our for MS14. So she's going to just help us move into MS15, and then she's going to move out. We've also got some advisors who've been around for with the team since MS12. So yeah, they've got a lot of knowledge we can tap into. Yeah, next slide. All right, so sub projects. It basically comes down to these. There's the powertrain motor interface, so we can communicate with like interface with the motors and making sure that we get the signals from them as we expect. Recharge and then DC-DC converter to make sure so we are getting voltage at a certain level, and not all the boards function at the same voltage. So the DC-DC converter basically brings it down to what we need, what the different components need. Then we have the battery management system. So yeah, if we don't, take care of our batteries properly, it's going to blow up the entire car in the middle of the race, and we don't want that. So yeah, we implement the battery management system as well, make sure everything goes smoothly. Then we have solar sense, the array layout, driver interface, like allowing the driver to like turn on their blinkers, right, left indicators, and yeah. Then we have telemetry. Since it's not, I believe we have a lead car as well, which we could communicate with. I'm not sure. That was for the. Do we have that? Can anyone answer? Okay, yeah, that's good. Yeah, we have a lead car. Yeah, so telemetry is to communicate with the lead car and make sure all systems work as it should. And then infrastructure. We have controller board and power distribution. Power distribution is basically a board that allows us to send power to the rest of the boards. And controller board is something that's pretty cool. It's where we have our microcontroller, and it's where firmware does all its magic. And yeah, so if you guys like playing with Arduinos and love this designing circuit part, you might want to join hardware, because that's where we do all these. We wire things up for firmware to take over. Yeah, next slide. So stuff that we do basically summarizes into like a couple of stages, and this is like the first part: schematic capture, PCB layout, and then physical board. So schematic capture is where you design your circuits, do all your calculations, make sure everything adheres to the specifications. Then we move on PCB layout, where we fit it all into a little board, which you can see there. So we design that board while we do the PCB layout, and then comes the physical board. And that what you see on the right. So when we design the layout, we send these to the manufacturer, and they send it back to us. And then you see all these components there. Yeah, we have to put them there. So I think before we used to hand solder them before. So we used to like literally go in close and make sure there weren't any. It wasn't like everything was as accurate as it should have been. But now I think we've got a pick and place machine, so it won't be as bad. Yeah. On a side note, so right now, since we've just started the design cycle for MS15, and we're just getting to schematic capture, I really think that now, especially for Midnight Sun or any design team, if you guys want to join, I think a time like this when we're just getting schematic capture would be ideal, because you guys can see it from the start, like from the very beginning. And I think that's pretty cool. And if you tell employers that as well, next call, they'd be like, oh, you know how to do this car from scratch. Like, come on. Yeah. Next slide. So yeah, if you guys stick around long enough, you can get experience in the next stages, which is board bring up, wiring, and harnessing. And yeah, here you get the soldering experience, as I mentioned, in which you can basically put the components on the board and make sure that they stay in place correctly. And yeah, then we test these boards, make sure there are no faults, there's no no short circuitry anywhere. And yeah, once we make sure that the boards function as they should, we hand them over to firmware, where Ryan, Mitch, and his team do their thing. Okay, next slide.
Hey, I'm Mitchell. I'm one of the firmware leads, and we've got Ryan here as well. And yeah, basically, like was said, we also help hardware in not blowing the car up. We're kind of the two teams that deal with the batteries and all the electrical systems. So we're basically in charge of writing low-level software for all of the electrical systems. So we're writing code for microcontrollers, and they do control all these kind of sensors and different interfacing parts that go together to make a car work. If you've ever done anything with Arduino or I don't know, Lego EV3, it's like that, but like a lot more stuff happening. So we write stuff mainly in C, and we're also responsible for taking care of our software. So writing tests and making sure that it's going to work and that it'll function and that we won't have errors when we go to race. Some of the things that you can learn if you join the firmware team, we've got like industry level embedded software, like all the practices that we have here and the technologies we use are used in industry as well. So they're all really good to know. And it's also right at the kind of like, I guess it's right at the level where you can actually see how things work. Like you don't have to deal with it through company infrastructure, I guess. And also like how to be a member of a software organization. We do code reviews, we get code through the development process and then into our repo. So that's a good experience as well. And I'll pass it off to Ryan.
Okay, so next slide, please. Yep. So hey, I am Ryan. I am the other firmware lead this term. I'm sort of transitioning down this term. But anyway, so if you join firmware, things that you will work on include things like battery management, protection. So as we've been saying several times, making sure that the car doesn't blow up, that'd be non-ideal. As well as driver controls, what happens when you push the button on the dashboard. So hardware makes mechanical or hardware makes the button and makes it go to our microcontrollers, and what happens after that. So then we take over there and make sure that the appropriate things happen when you select drive, we change into drive mode and stuff like that. Telemetry, so I think hardware talked a bit about this. Getting data off the car and into our chase car, into some cool UIs we've made for it, into the cloud, and into places where strategy can do stuff with it. Emulation, debugging tools has actually got, we finished up a couple of cool projects around that. So like, emulating all of our firmware on your computer so that you can have that running and catch bugs there, and even more stuff. So, if you join the team, you'll be working in embedded C. There's also some Python projects that we have going. And yeah, you'll be working on, really, really close to the metal. So it's like, if you've programmed before, what you've probably done is you're working on top of all kinds of layers of abstraction. Like if you type, print hello world, that gets translated through all kinds of layers of abstraction right down to the hardware before her. And you don't know the details of any of that. Like you're probably like writing in Python, so it's on top of VM and top of OS. Anyways, so what we write is like really close to the metal. There's only like you write your code and it runs pretty much directly on the microcontroller. And that's what's really cool because you have a lot of control over the microcontroller. So things we're doing this term, we're actually taking advantage of the fact that we're starting a new car. We're actually upgrading all of our core libraries. So we're trying to use this thing called FreeRTOS. It's a real-time operating system, which is an industry standard thing that a ton of car companies and also other solar car teams use. So we're transitioning to use that. We're also upgrading our build system and doing some preliminary redesigns for our system. So we'll all of those boards that Hardware talked about, we have a project that has the code for those. So we're starting some preliminary system designs for that. And in the future, we'll be working a lot on writing projects to control of those. So your team is me and Mitchell, those are your leads. We also have Fraj, Xicheng, and Jarvis as your core members. So that is firmware. Feel free to contact me or Mitchell if you have any questions about firmware.
Hey, can everyone hear me?
Yep,
you're good.
Okay, perfect. Hi, I'm Emma. I'm the lead for strategy. And Firmer talked about us a little bit, but basically what we do is try to guide a lot of decision making around how we're going to race. So in the original car, in the MS14 car, we were doing a multi-occupant vehicle, which was dictated by a certain optimization formula. And now since we're switching into a single occupant vehicle, we have to do a lot of revision on sort of that thought process and also reevaluate how we're going to actually optimize our speed and optimize the car as we build the understanding of the car and build the car itself. So there's a couple of high-level projects that we're going to be tackling this semester. The first is optimization. So as I mentioned, the purpose of the team itself is try to understand and also improve the team's performance when it comes to score. And that's what optimization deals with. Loops is a specific part of that. Some of the features that you'll see in race is the ability to do extra loops in order to gain mileage. And because a lot of the score is dependent on how much distance you've raced as well as the speed that you've raced it at, you want to be able to tell how many loops you can do with the given solar power that you have. So that's something that we're going to be starting on that we didn't really consider in our multi-occupant vehicle. And lastly, just overall, we have to do a lot of planning. The car itself is a work in progress and it's still being designed. And so as the understanding of that sort of develops, we'll have to adjust the models that we already have or develop new ones in order to fit that. People that have been on the team in the past, for example, might have worked on something called state of charge, and our understanding for multi-occupant vehicles is one way, and we're going to have to change that as we develop a new vehicle. The same sort of applies for our solar systems or for our motors as well. And so planning both the systems that we need in order to model the components of the car, but also the technologies that we're going to use as we race is part of what's going to go on this semester. So yeah, I've included 2 links on the slide. The first one is the strategy code from MS14. And then the second one is our onboarding. So how the semester is going to work is we're going to go through an onboarding process that introduces you to the tools that we kind of use, and then we're going to split into the projects that I mentioned. If you like using Python, we use almost entirely Python, so it'd be the team for you. And we also use GitHub to manage all our code since we're entirely remote. And you'll also find a lot of historic information on Confluence. There's a lot of just context that's worthwhile both in our team and also overall on the team within the Confluence page. So yeah, I only have one slide for today, but I'll talk more about everything on Saturday. The basics that we have to know is that we do a lot of coding and a lot of it's a little software focused, so a lot of data that we deal with. And if you like that type of thing, feel free to check us out.
Great, so back to me. As I mentioned before, my name is Gian. I am in 3B GBDA right now, and I'm the operation manager of the team and also a business lead. Hope everybody can hear me. But we have a lot of sub-leads in the team. We have Tiffany, Ashna, Amanda, Kelly, Fossey, and Lily in this team, and business is composed of 4 main teams that I'll be explaining briefly today. And if you do want to learn more about business, come out in the 101 meetings this Saturday. So first, one of the sub-teams is marketing. They will do a lot of design heavy work. So working on our brand, our Midnight Sun brand, websites, and social media presences such as like Instagram and Facebook. And we have our second team, finance. They will be keeping track of all the money related things, expenses that the Midnight Sun team does, and reimbursements, purchases, and organizing the overall budgets. Next slide, please. Now, we do have two teams called supplier interfacing and sponsorship. Both of the teams are very similar but different. I'll be explaining why. So both of them reach out to potential companies or other places for sponsorship. The main difference is that supplier interfacing look for in-kind sponsorship, meaning that they'll be reaching out to potential suppliers, companies, local companies for services or materials so that it can be helpful in our car manufacturing. While sponsorship will reach out to potential sponsors internally and externally for monetary sponsorship. Yes, and that is all for the business. I believe I do have one more slide. Next, please. So these are some of the past projects that we've been doing. Just because business is a very diverse team and we do a lot of stuff, there's obviously a diverse type of projects within the business team. First of all, for example, brand book was a past project that we did to make sure to figure out the brand identity of Midnight Sun. We have done crowdfunding in later terms as well, past few terms as well, so that you can see all the merch is there. And then social posts are still going on projects in marketing team. We would post about our potential sponsors or holiday posts and etc. Next, please. So now, which sub-teams should you join? Obviously, we went through 5 different big sub-teams. And if it really depends on what areas you're interested in. So for example, if you're interested in mechanical design, UI, UX, manufacturing, mechanical would be your team to sub-team to join. If you're interested in programming, software development, firmware, board and circuit design, hardware, graphic design, finance, talking to people, reaching out to people, business, data science and statistics, strategy. And yes, you can join more than one sub-team. It's just that you might have more workloads because you are joining multiple sub-teams. All right, next slide. Okay, so we are going to introduce some important next steps and important information so that you guys know what you need to move forward from today and on. Next, please. So as probably the leads mentioned often, please come out to the Midnight Sun onboarding 101 session happening this Saturday. For mechanical team, it's going to happen at 10 a.m. Eastern time. And for hardware, firmware, strategy, and business, it's going to happen at 1:30 p.m. Eastern time. All right, so that would be your next step. And after that, your sub-team leads would obviously guide you through on what to do next. And second, I see that some people already joined our communication channel. Awesome. So please join the UW Midnight Sun. Come join us. It's a Slack channel. And most of our communication happens there. Many of our meeting links will happen there. So please12 This is crucial. And come out to our weekly meetings, weekly general meetings starting next Wednesday, January 12th at 7 p.m. Most of our general meetings will be on that time, so Wednesday at 7 p.m. Except for today. So please join. Next slides. Okay, again, Midnight Sun onboarding 101 Saturday, January 8th, 10 a.m. for mechanical team. For other teams, it will be at 1:30 p.m. How to join. So we will be emailing shortly if you register through the first general meeting via Google form. So hang in there tight. However, the link will be posted on Slack on the general channel. So if you do join Slack, you'll be able to see that link on the general channel on Saturday. So for those of you who didn't register your email, this would be a best option. So please join Slack. And also, we will be sending out one link for the one-on-one sessions, please join any, no matter what, if it's mechanical, hardware, farmer, strategy, business, just please join with that one link. And that is it. If you, for example, if you are interested in mechanical team, please join the 10 a.m. meeting. If you are interested in strategy, please join the 1:30 p.m. meeting. Let's say if you're interested in mechanical and firmware, please join 2 of the one-on-one meetings. Next slide. Okay, so we will be going through some of the basic team tools that we use in Midnight Sun. So first, I mentioned Slack is the main channel for communication. All of the notifications, meeting links, communication will happen in Slack, so please join. Confluence is where we put all the project documentation. We will be sending you a link, hopefully, through here, so that you guys can see that our documentation, and we do have a friendly getting started page on our Confluence as well, so you should look through there. And Google Drive just for storing lots of notes and files, such as meeting notes, files, etc. Next, please. So Slack, we outlined the important channels for you guys. So #general for general announcement, meeting for meeting links and reminders, business, that should be self-explanatory, business for business team, mechanical for mechanical team, like hardware for hardware team, like firmware for firmware team, and Gen strategy for strategy team. Next, please.
Alrighty. Yeah, so team meetings, as Jen mentioned, starting next week, Wednesdays at 7 p.m. are the general meetings. And so that's a great place to just hop in, get a feel of what the other teams are doing. And 7:30, sub-team check-ins happen. And then Saturdays at 1 p.m., we have sub-team check-ins as well as at 1:30, working sessions start. Now, this is just a very broad kind of schedule. I think every sub-team has a different schedule that they follow. And so for your specific sub-team, just add the solar@uwmidsun.com calendar. That will give you all the information you need to attend the right meetings, and also just join the Slack channel of your respective sub-team, as well as the general channel on Slack. And then you can just scroll up and see when the meetings have occurred in the past, and they should stay relatively consistent to that. Next slide. All right, just some general advice. Number one, what you get out is what you put in. You'd be surprised at how much you learn when you do just put in, the effort. I think, I learned a lot. And so, like you will too. Just if you put in the time, then you will end up learning quite a lot. You'll be surprised. Number two, ask questions or ask for help. We're all students here. We're all here to learn. Everybody's on equal grounds. And so, like a lot of people just come in clueless. I know that was me at least. And so, just feel free to ask any one of us questions in the chat, in Slack, and we will be happy to get back to you. And the last point, be an active member on the team. We're looking for thinkers and doers. And so I think that's a goal of every student design team. In order to be productive, you got to be active. And as long as you're curious and willing to get your hands dirty, you'll do very well on this team. Next slide. Right, and then just who to talk to. As you see, here are all the sub-teams, and so you might want to write down some of the names of people who you want to message. And if you don't know yet, but you figure out later, or you still don't know, just message me for general questions. I'm always open to answer your questions. Next slide. All right, and that concludes the Winter 2022 First General for Midnight Sun. I hope you guys found some sub-teams that you were interested in, and I hope to see you guys soon in 101s and in future meetings. And so if you guys don't have any questions now, feel free to leave. I hope you guys have a great term and a great year. for those who do have questions, I, along with most of the other leads, will be sticking around for a bit longer to answer them. But yeah, thanks guys. Very exciting. As you know, as we mentioned, it is a brand new team, and oh no, not brand new team, but it is a brand new cycle. We are starting a brand new car, and it's very exciting to create a car from scratch instead of just tossing on some stickers at the very end. So yeah, I hope you guys join us for the ride. See you guys.